Hello everyone, good morning. How are you? Yes, so today we are going to talk about the further P block elements about group 15 and 18. Okay, so can you tell me whether I am audible to you and my screen is visible to you? Yeah, yes, thank you so much for responding. So today, let's start with the group 15 and 18 elements. As I have shown here in the slide, that group 15 and 18 elements, right? So yesterday we have talked about group 13 and 14 elements. That is boron and carbon family. Okay, boron and carbon family, we have talked about these, right? So today we are going to talk about 15 to 18. Okay, group 15 to 18. So which are those group 15 to 18? So nitrogen family, oxygen family, right? Nitrogen family, oxygen family, fluorine family, that is, those are halogens and noble gases. Okay, and noble gases. So these are what our group 15 to 18 elements. Okay, nitrogen family, oxygen family, fluorine, and then like this way, halogen atoms. Okay. So can you tell me the answer for this? Yeah. Let's start with solving certain problems of this. Okay. Yes. Can you tell me the answer of this? Yeah. What will be the answer for this question? I have shown you the options also. Yes. A, B, C, D. We just want to, what we need to do here is we should match the column 1 with the column 2. Okay. We just need to match the column 1 with the column 2. So can you tell me the answer here? What will be the answer? Yes. Okay. Yeah, what will be the answer? Okay. So see here, what will be the answer? Option A. Okay. Why is it so? So X3, as we see, it is what? Which shape? It is of which shape? Linear. Okay. Since there are only two atoms present, so here X represent one atom and X dash represent different atom as compared to X. So when two atoms are there, you know the shape will be linear. Okay. So that's why for A, it is a linear. These are 3 and 1. 4 atoms are present. Okay. Central atom will be 1 and surrounded by the 3 atoms. So it is going to have shape T shape. So that's why T shape. Next 5 atoms are surrounding to a central atom. So that's why when we see the structure of this, it is what? Square pyramidal in shape. And next 7 atoms are surrounded to a given atom. So it is what? Pentagonal bipyramidal in shape. So here option A is the correct answer. Right? Okay, next problem. In which pair of ions both the species contain SS bond? So here we need to find out the SS bond in which species are present, A, B, C, D. So there are 2 species in each option and we need to see whether the SS bond is present in which option. So see here the structure of S4O6 2 minus. Okay, does it contain SS bond? Yes, it contains the SS bond. So S4O6 2 minus contains the SS bond. Next is S2O3 2 minus, that is S2O3 2 minus present in this option A. So here also you can see there is a SS bond, right? But when you see different species like H2O7 and H2O8, now you will observe that there is no SS linkage. There is what? Oxygen present in between that SS. So that's why option A is our correct answer. You can see from the structure also. Okay. Any doubts regarding this? Okay, let's go on to the next problem. Match the compounds given in the column 1 with the column 2. Okay, so here we are solving certain PYQs of these P block elements. I have combined all the PYQs from 15, 16, 17 and 18, and we are going to solve them in order to understand the phenomena present in this given chapter. Okay, sorry. Match the compounds given in column 1 with the column 2. Okay. First molecule XCF6, XCO3, XCOF4, XCF4. So we need to match the structures with the molecules. Okay. So here let's see XCF6. So XCF6, due to presence of one lone pair of electron on the xenon atom, it shows, even though 6 atoms are there, it should be showing octahedral structure, but it shows distorted octahedral structure due to the presence of the lone pair of electron on it. Okay. Next XCO3, you can see here the structure of XCO3 is what? Trigonal pyramidal. Okay, it is what? Trigonal pyramidal, presence of one lone pair of electron. Next element, next molecule XCOF4. Okay, this is XeOF4. Here you can see the structure of it is square pyramidal. Okay, next is what? Square planar, that is XCF4. ठीक है, 2 इलेक्ट्रॉन पेयर है उस पे, ज़ेनॉन पे 2 इलेक्ट्रॉन पेयर है, यहाँ पे एक ही था, यहाँ पे भी एक था, लोन पेयर्स. Okay, pair बोल रही हूँ मैं. Okay, any doubts? So the structures are shown here. So when we match this structure with the options, now you can see option C is the correct answer. Okay, any doubts? Let's move on to the next problem. Which of the following is the correct statement for the given acid? So there are 2 acids given here, phosphinic acid and phosphonic acid. Okay, phosphinic acid is monoprotic, while phosphonic acid is diprotic. Phenic acid is diprotic and phonic acid is monoprotic. Both are diprotic, both are triprotic. So first of all, we need to understand the structure of both the acids. Okay, phosphinic acid as well as monoprotic acid. Okay, phosphinic acid as well as phosphonic acid. ये दोनों के structure देखिए. This is what? Phosphinic acid. This is what? Phosphinic acid, and this is what? Phosphonic acid. So the structure are what? H3PO2 and H3PO3. That is the difference between phosphinic and phosphonic. So when you see the structure here, you can see here 1 OH is contained, and this molecule contains 2 OH in its structure. Okay. First molecule contains only 1 OH in its structure, and second molecule contains 2 OH in its structure. So that's why first one is a monoprotic, since it contains 1 OH. Okay, and it is useful. So ये H क्या करेगा? वो एसिड दे सकता है, ठीक है, हाइड्रोजन नहीं दे सकता. OH वाला जो हाइड्रोजन है वो दे सकता है, ठीक है. That's why it contains only 1 hydrogen to give. That's why it is a monoprotic acid. यहाँ पे 2 OH होने के कारण it can give 2 hydrogen atoms, and that's why it is diprotic. So which among the following statements is correct here, everyone? So here, which statement will be correct? First statement will be correct. That is, phosphinic acid is monoprotic, containing only 1 OH group. On the other hand, phosphonic acid is a diprotic which contains 2 OH group. Right? Any doubts? Okay, let's move on to the next problem. Which one of the following order is correct for the bond dissociation enthalpy of halogen molecule? So here we need to talk about the bond dissociation enthalpy for halogen molecule. So you know the order of bond dissociation enthalpy for all the halogens is what? This. Cl2 और Br2 और F2 और I2. Okay, bond जो है हमको break करना है, ठीक है. होमोन्यूक्लियर जो मॉलिक्यूल है यहाँ पे Cl, Cl, Br, Br, ठीक है, फ्लोरीन, फ्लोरीन, आयोडीन, आयोडीन, इन लोगों का बॉन्ड ब्रेक करने के लिए who will require the more energy? So Cl will require more energy, then bromine, then fluorine, and then iodine. Okay, yeah. Next problem, when copper is heated with concentrated HNO3, it produces. So what does it is going to produce? So see here, we need to find out we need to consider the reaction here. So when copper, you can see here copper, Okay, copper when heated with HNO3, that is concentrated nitric acid, what is it producing? Here CuNO3 twice, NO2 and H2. So which of the option here is correct? So it is giving us NO2. तो यहाँ पे NO भी दिया हुआ है, ऑप्शन ए में नहीं चलेगा ये, ठीक है, यहाँ N2 ये भी नहीं चलेगा, यहाँ NO2 दिया है, या so this is correct option. This is also not correct. So option C is correct answer here. Okay guys, next question. Among the following, the correct order of acidity is. So we have given the acids. Okay. So these are what? Oxo acids. These are what? Oxo acids. Okay. So we need to consider here acidic character for these oxo acids. So the acidic character for this oxo acid goes on increases as there is an increase in the oxidation number of a given halogen atom. Present in this oxo acid. So for chlorine, we need to find out how the oxidation number increases. So here you can see from 1, 2, 3, 4, the oxidation number goes on increases. Okay, how this can be explained on the basis of relative stability of anions left after the removal of proton. So when the proton goes from HClO, okay, HClO2, HClO3, when the anion gets formed, na, okay, so the stability of that anion determines the correct order of a given acid. Okay, so the stability of anion decreases in the order. So the stability go on decreases for this like this way. ClO4 minus, then ClO3 minus, then ClO2 minus, then CO minus. So acid strength also decreases in the same order. So that's why acidic strength is going to decrease in the same order. So which will be the great acid? So here you can see oxo acids, HClO4 will be more acidic, then HClO3, then HClO2, then HClO. Are you getting it? Do you understand this? This is the phenomena which is we need to consider here in order to determine the order of acidity for these oxo acids. Okay, you can consider by using this also. As oxidation number increases, acidity also increases. Or after giving acid, the species which will be remain, whether it is stable or not stable, according to its stability, you can also find out which acid will be more acidic. Okay, very good. Next problem, strong reducing behavior of H3PO2 is due to. So this oxo acid of phosphorus, that is H3PO2, is what have strong reducing behavior. So why is it so? Due to high electron gain enthalpy of phosphorus, due to high oxidation state of phosphorus, due to presence of 2 OH groups and 1 pH bond, and due to presence of 1 OH group and 2 pH bond. So here, first of all, let's see the structure of this phosphoric acid. Okay, here you can see just now, right now we have talked about this phosphinic acid. It contains only 1 OH group. Okay, it contains only 1 OH group and 2 pH group. So all oxo acids of phosphorus which have pH bonds, and these pH bonds acts as a reducing agents, and these pH bonds acts as a reducing agent. Okay, so this H3PO2 molecule contains 2 pH bond, and that's why it acts as a what? Strong reducing agent. That is what the important point here in order to act as a reducing agent. उसमें 2 हाइड्रोजन है, इसलिए वो रिड्यूसिंग एजेंट जैसे एक्ट करता है. ठीक है, ये 2 OH है और एक pH, ये तो गलत ही है ना. ठीक है, हाई ऑक्सीडेशन स्टेट ऑफ फॉस्फोरस, हाई इलेक्ट्रॉन gain enthalpy, this is also not correct. Okay, in terms of reducing power, we are not going to consider those. Next problem, the variation of the boiling points of the hydrogen halides is in the order of HF, HI, HBr, HCl. Okay, so the boiling points are in this order. What explains the higher boiling point of hydrogen fluoride? So why does hydrogen fluoride is having the highest boiling point? So you know the fact, right? Do you know the fact about hydrogen bonding? Yes. So there is a strong hydrogen bonding between HF molecules. Next, the bond energy of HF molecules is greater than in other hydrogen halides. The effect of nuclear shielding is much reduced in fluorine, which polarizes the HF molecule, and the electronegativity of fluorine is much higher than for other elements in the group. So here, what do we need to consider is hydrogen bonding. So that's why our answer is correct. Okay, option A जो है वो हमारा correct होगा. Because HF forms very strong intermolecular hydrogen bonding. Why? Because of its high electronegativity. Okay, because of the high electronegativity of fluorine atom. Hence, the boiling point of HF is abnormally high. Boiling points of other hydrogen halides gradually increase from HCl to HI due to the increase in the size of halogen atom from chlorine to iodine, which further increases the magnitude of van der Waals forces. So, जैसे जैसे हम लोग आगे जाएंगे ना, वैसे 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 हमारे जो boiling points है वो बढ़ रही है. Why? Because the size of the atom is increasing. So that's why HCl is at the last. ठीक है, लेकिन HF के लिए ज्यादा है. क्यों? क्योंकि इट इज शोइंग अ गुड इंटरमोलिकुलर हाइड्रोजन बॉन्डिंग वो शो कर रहा है इस वजह से. Right? So our option A is the correct answer here. Any doubts here? Yes? Okay, now let's move on to the next problem. Which of the statement given below is incorrect? So there are 4 statements given to us. O3 molecule is bent. ONF is isoelectronic with O2N minus, and OF2 is an oxide of fluorine, and Cl2O7 is an anhydride of perchloric acid. So first statement is correct. O3 is bent shape. Okay. Next, ONF is isoelectronic with O2N minus. So here we need to calculate the number of electrons present in both the spaces. So number of electrons present in O and F. Calculate that. If they are matching with O2N minus, then we can say that the spaces are isoelectronic with each other. Okay. यहाँ पे जो number of electrons आएंगे, if they are matching with the number of electrons present in this spaces, you can say that they are isoelectronic with each other. Okay, यहाँ पे कितने ऑक्सीजन में कितने हैं? Yes, how many? Can you tell me? 6 plus 7 plus 8. यहाँ पे 6 6 12 plus 7 plus 1. Okay, माइनस चार्ज है ना, इसलिए प्लस 1 किया. तो यहाँ पे देखिए कितने आ रहे हैं हमारे पास एलिमेंट्स, इलेक्ट्रॉन्स. 6 plus 7 plus 8. How many? How much is it happening? Yes, yes, yes. Tell me. Just it is just a simple maths. Yeah. Can you tell me the answer? Yes. Yes. आ रहा है क्या आंसर? नहीं आ रहा है आंसर. यस. तो यहाँ पे हमारा जो आंसर है ना, जो इनकरेक्ट है, कार्बन के लिए 4 है, यहाँ पे 5 है, यहाँ पे 6 और यहाँ पे 7. ठीक है, तो मैंने यहाँ पे क्या किया, यहाँ पे 5 लेना चाहिए था और यहाँ पे 7 लेना चाहिए. कि नाइट्रोजन के लिए हमारे पास है 5. राइट. सो 6 plus 5 plus 7. हाउ मेनी? 6 plus 5 plus 7. यस, 6 plus 5 plus 7. There are 18 electrons. और यहाँ पे 12 plus 5 plus 1, there are 18 electrons. So both are isoelectronic features. This statement is again correct. The third statement is what? Incorrect. So when we talk about OF2 now, OF2, when we talk about OF2 is a fluoride of oxygen, because fluorine is more electronegative than oxygen. Okay, because fluorine is more electronegative than oxygen. So it is what? Oxygen difluoride. Okay, is an oxide of fluorine. लेकिन यहाँ पे क्या बताया गया है? That is what the incorrect statement. Okay, OF2 is what? Oxide of fluorine. ये जो बात है ये गलत है. ठीक है, so our correct answer is this one. Next, the formation of. So यहाँ पे हम लोगों को एक क्वेश्चन दिया हुआ है. यहाँ पे ऑक्साइड आयन का फॉर्मेशन किया हुआ है O2 minus from these two reaction 1 and 2. Okay, यहाँ पे oxygen atom requires first an exothermic and then endothermic step. So first of all, first one is the exothermic step and another one is the endothermic step. Okay, so the process of formation of this ion in a gas phase is unfavorable, even though O2 minus is isoelectronic with neon. It is due to the fact. So due to which fact it is happening? So O minus ion has a comparatively smaller size than oxygen atom. Oxygen is more electronegative. Addition of electron in oxygen results in the larger size of the ion, or electron repulsion outweighs the stability gained by achieving the noble gas configuration. So here, what is the answer actually? So here answer is what? D. तो यहाँ पे क्या होता है ये जब रिएक्शन होती है एक्सोथर्मिक और एंडोथर्मिक, सो यहाँ पे फॉर्मेशन जब हमारा O2 माइनस का हो रहा है, देयर इज अ फॉर्मेशन ऑफ O2 माइनस in a gas phase, this is unfavorable even though O2 minus is isoelectronic with neon. Even though O2 minus is isoelectronic with neon. Why? Because यहाँ पे क्या होता है, due to the repulsion, यहाँ पे क्या होता है, ये बात होती है, due to the electron repulsion outweighs the stability gained by noble gas configuration. ओके यहाँ पे इलेक्ट्रॉन का इतना रिपल्शन हो रहा है कि उस वजह से नोबल गैस कॉन्फ़िगरेशन से भले ही उसको स्टेबिलिटी मिल रही हो, even though it is getting the stability by acquiring the noble gas configuration, it won't be doing that. Okay, because the electron repulsion is so much larger here. Okay, so when one electron gets added to O minus ion, now there is a strong electrostatic repulsion between these two negative charges, and due to this, the second one जो electron gain enthalpy है ना for oxygen, it is what? Positive. Okay, that's why it is what? Positive. So this is our correct option, right? Yeah, do you understand this? Okay, next problem. Nitrogen dioxide and sulfur dioxide have some properties in common. Okay, NO2 और हमारा जो SO2 है, उन दोनों की जो properties है वो somewhat common है. Which property is shown by one of these compounds but not by the other? So हम लोगों को 4 options दिए हुए, उनमें से which property is shown by one compound but not by other? So first one is soluble in water. Second one is used as a food preservative. Third one is a form and acid rains. Fourth one is a reducing agent. So here, one property which can be shown by one compound but not by other is that this one, option B. Okay, this one is the correct answer. Here, you know that. If you don't know that, I will tell you that NO2 gas, okay, NO2 molecule is what? Is not used as a food preservative. ठीक है, ये फूड प्रिजर्वेटिव जैसे एक्ट नहीं करता है, ठीक है. बट व्हेन वी टॉक अबाउट बोथ द सब्सटेंसेस ना, दे आर सोल्युबल इन वाटर, दे फॉर्म एसिड रेन एंड दे एक्ट एज अ रिड्यूसिंग एजेंट, बट NO2 is not used as a food preservative. ठीक है, that's why that will be our correct answer, option B. Next, acidity of diprotic acid in aqueous solution increases in the order. So here we need to consider the acidity for these acids. Okay, so as the atomic size goes on increases down the group, the bond length of these acid also increases, and that's why the bond strength decreases. So the cleavage of element to hydrogen bond becomes easier, and that's why more will be the acidity. The correct order is this much. So हम लोग जैसे जैसे नीचे जा रहे हैं ना, तो ऑक्सीजन है, सल्फर है, ठीक है, सेलेनियम है और टेलेरियम है. तो जैसे जैसे हम लोग नीचे जा रहे हैं ऑक्सीजन फैमिली में, हमारा एटॉमिक साइज क्या हो रहा है? बढ़ रहा है. इट इज गोइंग ऑन इंक्रीजेस. सो द बॉन्ड बिटवीन हाइड्रोजन एंड सल्फर, द बॉन्ड बिटवीन हाइड्रोजन एंड सेलियम, एंड द बॉन्ड बिटवीन हाइड्रोजन एंड टेलिरियम, it is going on increases, and that's why it becomes easy to break. Also it becomes easy to break. So जितने easily हाइड्रोजन दे सकता है मॉलिक्यूल, उतना अच्छा क्या होता है वो? Acid. That's why the order will be like this way: H2S less than H2AC than H2P. Right, guys? Any doubts? Please consider the order like this way. Okay. Next, which is the strongest acid among the following? So here we need to consider which acid is strongest: HClO4, H2SO3, H2SO4, HClO3. So which acid is strongest? Yes. Any answers? Okay, so here HClO4 is a strongest acid. Why? Because it is having highest oxidation number and its conjugate base is resonancely stabilized. Hence it is most acidic. So HClO4 में जो हम हाइड्रोजन देंगे, ठीक है, उसके बाद जो स्पेसीज फॉर्म हो रही है, this species is again resonantly stable. Okay, chlorine is more electronegative than sulfur, and that's why ये कंपाउंड तो उससे ज्यादा एसिडिक नहीं हो सकता. यहाँ पे जो क्लोरीन का अदर स्पेसिस कॉन्जुगेट बेस जो फॉर्म होने वाला है वो स्टेबलाइज होगा, लेकिन इसका जो ऑक्सीडेशन नंबर ये कम होगा एज कंपेयर टू HClO4, और सल्फर से ज्यादा क्लोरीन इलेक्ट्रोनेगेटिव होने के कारण दैट इज व्हाट अवर गुड एसिड. ठीक है, तो 14 का आंसर क्या है हमारा? ऑप्शन. एनी डाउट्स? या हमको ऑक्सीडेशन नंबर का ध्यान रखना है जब हम लोग ऑक्सी एसिड के बारे में बात करेंगे तब, और उसके बाद उसका जो कॉन्जुगेट बेस फॉर्म होने वाला है, the stability of that, and then again if there are certain different oxo acids present like sulfur oxo acids, so we need to consider the electronegativity factor, right? Okay, next problem. Which one of the following molecule contain no pi bond? So here SO2, CO2, NO2, H2O, we know the structures of these, right? We have studied in chemical bonding. Even though we have seen the structures of these, you can easily say which doesn't contains the pi bond. Okay, so H2O molecule, you know H2O molecule, it is a simple structure. It only contains sigma and sigma bond. Okay, it only contains sigma and sigma bond. There is no pi bond present in this molecule. So our option D will be the correct answer, right? Okay, next, which of the following does not give oxygen on heating? तो यहाँ पे हम लोगों को 4 मॉलिक्यूल्स दिए हैं, इनको हम लोग हिट करेंगे, हिट करके उनका रिएक्शन देखेंगे, हम लोगों को ऑक्सीजन मिल रहा है कि नहीं वो देखते हैं, ठीक है? ऑप्शन ए में क्या दिया है हम लोगों को, K2Cr2O7, ठीक है, K2Cr2O7 दिया हुआ है, उसको हिट करो, आप लोगों को क्या मिलता है, K2Cr4, Cr2O3, और यहाँ पे मिल रहा है हमको ऑक्सीजन, ठीक है? तो यहाँ पे ऑक्सीजन मिल रहा है। KClO3 हमारा ऑप्शन सी है, ऑप्शन सी में देखिए हिट किया, KCl मिल रहा है और ऑक्सीजन मिला है, तो यहाँ पे भी ऑक्सीजन मिल रहा है। नेक्स्ट ऑप्शन डी देखिए, ऑप्शन डी में आपको देख सकते हैं ZnClO3 ट्वाइस, इसको हिट किया, ZnCl2 मिल रहा है और ऑक्सीजन मिल रहा है। सो ऑल दीज 3 ऑप्शंस वी आर गेटिंग द ऑक्सीजन, बट इन ऑप्शन बी, व्हाट इज हैपनिंग इन ऑप्शन बी, NH42 Cr2O7, when we hit this compound now, what is happening, we are getting N2 Cr2O3 and water, we are not at all getting oxygen. So this will be our correct option, that is we never getting here oxygen atom on heating. Okay, we are not getting oxygen atom on heating. Any doubts regarding this? We are just hitting the molecule and we are observing whether we are getting oxygen or not. Okay, next, identify the incorrect statement. So here we need to find out which statement is incorrect. Okay, first of all, incorrect statement हम लोगों को ध्यान में रखना है. Regarding the XeO4 molecule, incorrect statement. XeO4 molecule is square plane. There are 4 p-pi bonds. There are 4 sp3p sigma bonds. XeO4 molecule is tetrahedral. So which among the following is what we can say incorrect statement? You know XeO4. फर्स्ट प्रॉब्लम में हम लोगों ने देखा, सेकंड प्रॉब्लम में कैसा होता है स्ट्रक्चर XeO4 का? यस, its structure is actually square plane. So this is correct. There are 4 p-pi d-pi bonds. Yes, this is also correct statement. Okay, you can see the structure of this. Okay, यहाँ पे आप लोग देख सकते हो, ठीक है? तो हमारा जो मॉलिक्यूल है, ठीक है, इनकरेक्ट स्टेटमेंट हमारा क्या होगा? यस, इनकरेक्ट स्टेटमेंट हमारा क्या होगा? XeO4 is square planar, राइट? तो ये जो हमारा स्टेटमेंट है ये हमारा गलत है, सॉरी, it is tetrahedral in shape. Okay, it is tetrahedral in shape. It is having sp3 hybridization containing p and sigma bond. This is correct. The molecule is tetrahedral. This is again correct. ठीक है, XeO4 is not square planar. Incorrect statement वो होगा. Next, in which of the following compound nitrogen exhibits highest oxidation state? So try to calculate the oxidation state. We have seen so far so many examples of calculating the oxidation state. Let's try to determine it very fastly. N2H4 determine करो कितना आएगा, नाइट्रोजन का we don't know, तो X लिखो, कितने नाइट्रोजन 2 है, हाइड्रोजन कितने हैं 4 है, तो लिखो 4 के कितने होंगे, 4 into +1, ठीक है, कैलकुलेट करो, आपको मिल जाएगी ऑक्सीडेशन स्टेट 2x + 4 = 0. 0 क्यों लिखा है? बिकॉज द मॉलिक्यूल इज न्यूट्रल, सो यू आर गेटिंग x = -2. ठीक है, N2O4 का कितना है ऑक्सीडेशन नंबर? -2. ऑक्सीडेशन स्टेट -2 है नाइट्रोजन का. NH3 में देखिए कितना है, x + 3, तो x = -3. x = -3. नेक्स्ट, N3H में कितनी है ऑक्सीडेशन स्टेट? -1/3. तो हियर वी आर गेटिंग -1/3. NH2OH में देखो कितनी है, x = -1. Okay, so among all these, which is having the highest oxidation state? Yes, -2 ज्यादा है, -3 ज्यादा है, -1/3 ज्यादा है, या -1 ज्यादा है. So when you calculate all this, -1/3, how much will be it? Yes, माइनस में सबसे छोटा कौन सा है? वही है. So that's why this is what our highest oxidation state. Okay, that is what our highest oxidation. क्योंकि निगेटिव में जितना आप बढ़ा के जाओगे उतना वो कम होती है वैल्यू, ठीक है, इसलिए निगेटिव में जितनी छोटी वैल्यू वो ज्यादा होती है. आर यू गेटिंग दिस? राइट. सो ऑप्शन सी इज करेक्ट, विच इज हैविंग -1/3 ऑक्सीडेशन स्टेट. राइट. Yeah, next, which of the following statement is not valid for oxo acids of phosphorus? So oxo acids of phosphorus, we have seen about phosphonic as well as phosphinic acid, H3PO3 as well as H3PO2. Right? Which of the following statement is not valid? We need to consider which statement is not valid here. Orthophosphoric acid is used in the manufacture of triple superphosphate. Hypophosphorus acid is a diprotic acid. All oxo acids contain tetrahedral 4-coordinated phosphorus. All oxo acids contain at least one P double bond O unit and one POH group. So here, when you talk about the phosphoric acid, okay, all the oxo acids of phosphorus, which statement is not valid? So option B. Here you can see for hypophosphorus acid, it only contains one OH bond. That's why it will be monoprotic in nature. It won't be diprotic in nature. Okay, that's why hypophosphorus acid, which we already called as a phosphinic acid, is what? Monoprotic in nature. It won't be diprotic in nature. And this is what our answer here. This is, we need to consider the not valid statement. ठीक है, बाकी जो स्टेटमेंट है, बाकी के जो स्टेटमेंट्स है, those are what? Correct statement. Right? Yeah. Next, move on to the next problem. Sulfur trioxide can be obtained by which of the following reaction? So we are heating these molecules, okay, and we need to find out with the help of which reaction we are going to get the sulfur trioxide. That is what? SO3. Okay, that is what? SO3. So when you heat calcium sulfate plus carbon, when you heat ferrous sulfate, when you heat H2SO4 with sulfur, and when you heat H2SO4 with PCl5, among all these reaction, option B. Here, see the reaction, what is happening? We are getting Fe2O3. Okay, we are getting Fe2O3 and we are getting SO3. So that's why this option will be correct. Okay, everyone. So option B is correct option here. Next problem. In which of the following arrangements the given sequence is not strictly according to the property indicated against it? So हम लोगों को 4 options दिए हैं, and before that the something is written: increasing acidic strength, increasing pKa value, increasing acidic character, increasing oxidizing power. So on each thing, something is written, and we need to find out which of the following arrangements the given sequence is not strictly according to. तो कौन से match नहीं हो रहे property, वो हम लोगों को देखना है. So acidic strength of hydrides increases with increase in molecular mass. So हमारे जो hydrides है ना, उनकी जो acidic strength है, वो क्या होती है? As the molecular masses increases, they increases. Okay, so the order of acidic strength is like this way: HF, then HCl, then HBr, then HR. Similarly, for H2O, H2S, HSC, tellurium. Similarly, nitrogen के halides, nitrogen, phosphorus, arsenic, and Sb. So as the acidic strength is going to increase ना, pK value क्या होगी हमारी? Decrease होगी. तो उसका उलट होगा, ठीक है, उसका क्या होगा? Completely reverse of that will going to happen for the pKa value. So here in option B, what has been given is as acidic strength increases, the pKa value is also increasing. So this is not matching with the actual theory. So that's why this option is not correct. Right? ये correct है, ये correct है, ये भी correct है, ठीक है, ये हमारा गलत था. Next problem, oxidation states of these compounds. Okay, यहाँ पे हम लोगों को phosphorus की oxidation state निकालनी है इन सब में. You know how to determine the oxidation state, right? If you don't know, let's try to solve one by one. So H4P2O5, H4P2O5. So here you can see we need to find out the oxidation state for phosphorus. So phosphorus we are going to consider X. For oxygen, we know oxidation state is -2. For hydrogen, we know oxidation state is +1. Overall molecule doesn't have any charge, so it will be 0. So 2x minus 10, यहाँ पे +4 equal to 0. So 2x minus 6 will be equal to 0. So 2x is equal to 6. So x is equal to 6 by 2, that is equal to 3. Right? That is equal to 3. So first molecule में हमारा जो oxidation state है phosphorus का वो क्या है? +3. Similarly, for another molecule, it is +4. Similarly, for third molecule, it is +5. So 3, 4, 5. 3, 4, 5. Where is the answer? 3, 4, 5. Yeah, option D. Yes, 3, 4, 5. To understand how we are going to determine for oxidation state for hydrogen is +1, for oxygen it is -2. Okay, next. How many bridging oxygen atoms are present in this molecule? P4O10. Okay, P4O10. इसमें कितने हमारे पास ब्रिजिंग ऑक्सीजन एटम प्रेजेंट है? ठीक है, तो स्ट्रक्चर देखिए P4O10 का, आप यहाँ पे देख सकते हो फॉस्फोरस, वहां पे लिखा हुआ है आप लोगों को, दिस इज फॉस्फोरस, right? This is another phosphorus, this is another phosphorus. Yeah, you can see this structure. Yes, everyone. Yeah, here you can see oxygen is present here, oxygen is present here. So there are two oxygen, sorry, which are bridging. वो bridge में है, ठीक है? They are present in between two atoms. Okay, they are bridging in between two atoms. Again, how many oxygen are present here? Here also it is present in bridging. Okay, दो p के बीच में है, ये भी दो p के बीच में, ये भी दो p के बीच में. So green आप देख सकते हो, I have highlighted with the green color. How many oxygens are present in between? यहाँ पे ये सिंपली प्रेजेंट है, सिंगली प्रेजेंट है, ठीक है, डबल बॉन्ड करके. तो टोटल 6 ऑक्सीजन एटम्स है which are present bridge. Okay, which are present as the bridging oxygen atoms. So option C, oh sorry, option A is the correct answer. 6. Okay, yeah. Any doubts regarding this? Okay, let's move on to the next problem. Among the following, which is the strongest oxidizing agent? So here we need to find out the strongest oxidizing agent. So do you know which is the strongest oxidizing agent? Yeah, we have seen this also in electrochemistry. Br2, I2, Cl2, F2, which is the strongest oxidizing agent? Yes, F2 is the strongest oxidizing agent since it has standard reduction potential positive. Okay, it has standard reduction potential positive. Okay, and you know that standard reduction potential goes on decreases from fluorine to iodine. So जिसका standard reduction potential ज्यादा होगा वो क्या होगा, ज्यादा अच्छा क्या होगा, oxidizing agent, right? So standard reduction potential of halogen are positive and it decreases from fluorine to iodine. So F2 is the strongest oxidizing agent. ठीक है, बात ध्यान में रखना है. Next, the angular shape of ozone molecule consists of. So you know that molecule O3, that is हमारा ozone molecule, इसका shape कैसा होता है, angular shape होता है. तो अगर आपने उसका structure देखा, ठीक है, you can see the shape of the ozone molecule here. Yeah, you can see there is one double bond and one single bond present, and this molecule is completely in resonance. Okay, कभी यहाँ पे double bond होता है, कभी यहाँ पे double bond होता है, completely resonance में होता है. Okay, so these are the two Lewis structures available, structure 1 and structure 2. In both the structure, you can see there are 2 sigma bonds. Yeah, 2 sigma bond and 1 pi bond is present. So what will be the correct answer here? 1 sigma 1 pi, 2 sigma 1 pi, 1 sigma 2 pi, 2 sigma 2 pi. So 2 sigma and 1 pi will be the correct answer. Right? Any doubts in this? O3 का स्ट्रक्चर आप लोगों को पता है, ये तो बहुत ही सिंपल मॉलिक्यूल है, हम लोगों ने इसका स्ट्रक्चर केमिकल बॉन्डिंग में भी देखा है. सिंपल था, कितने सिग्मा बॉन्ड है और कितने पाई बॉन्ड है, राइट? वेरी गुड. नेक्स्ट 27. Which of the following orders correctly represents the increasing acidic strength of the given acid? Yeah, can you tell me the increasing acidic strength for these acids? I have told you already. Yes, ABCD कैसे हम लोग देखते हैं, ऑक्सीडेशन नंबर ऑफ सेंट्रल निगेटिव एटम शुड बी मोर. इसमें है, देखो ऑप्शन डी. क्या हो रहा है ऑप्शन पे, देखिए HOCl, HOCl2, HOClO3 and HOClO. So the oxidation number of every chlorine atom present centrally is going to increase. So number of oxygen atom increases and increasing amount of electron density shifts from chlorine atom to more electronegative oxygen atom. Hence the oxidation number of chlorine atom increases and the actual amount of actual positive charge on chlorine atom increases, which in turn attracts the electron density from OH bond, and hence OH bond is weakened as the proton is easily released and acidity decreases. तो यहाँ पे मैंने ये एक्सप्लेनेशन क्या दिया हुआ है कि देखिए जैसे जैसे हमारा पॉजिटिव चार्ज इंक्रीज हो रहा है क्लोरीन पे, as the positive charge goer increases on chlorine atom, what happens is that the bond between O and H becomes what? Positive charge इस पे फॉर्म हो रहा है. So what it will do, it will pull the electron density towards itself from the oxygen atom, and that's why hydrogen will become loosely bound to this given electronegative oxygen atom. So as it will become less loosely bound to oxygen atom, it is free to move, it is free to give out, it is free to go anywhere. That's why as the positive charge increases na, वो जो capacity है, the capacity of pulling the electrons from oxygen increases, and that's why the O and H bond becomes less drawn, or less, it becomes weak, and as it becomes weak, the H hydrogen can go anywhere easily. So that's which is a good acid. HO4 is a good acid. Yes. Next problem, the electronegativity difference between nitrogen and fluorine is greater than that between nitrogen and hydrogen. Yet the dipole moment of NH3 is larger than that of NF3. Why is this happening? So this is because which case? So you know, the dipole moment of NF3 is what? 0.24 D. Okay, यहाँ पे 2D दिया हुआ है, ठीक है, यहाँ पे 2D दिया हुआ है, लेकिन NF3 का डाइपोल मूवमेंट कितना है हमारे पास? Let's see, it is 0.2 D. Okay, and that of NH3 is how much? It is 1.48 D. हमको प्रॉब्लम में कितना दिया है? 1.5 अराउंड, हम लोगों को 1.5 दिया हुआ है प्रॉब्लम में, ठीक है। तो यहाँ पे हम लोगों को बोला है कि इलेक्ट्रोनेगेटिव डिफरेंस बिटवीन नाइट्रोजन एंड फ्लोरीन इज वेरी ग्रेटर देन दैट ऑफ नाइट्रोजन एंड हाइड्रोजन, yet the dipole moment of NH3 is more as compared to NF3. Why is this happening? Why is this happening? Because in NH3 atomic dipole and bond dipole are in opposite direction, whereas in NF3 they are in the same direction. So हमारे पास चार ऑप्शन दिए हैं, ये मैं पढ़ नहीं रही हूँ, बहुत बड़े बड़े हैं. I will just only explain you. Okay, NH3, in NH3 as well as NF3 atomic dipole, bond dipole are in same direction. In NH3 atomic dipole and bond dipole are in same direction, whereas in NF3 they are in opposite direction, or like this way. So जब हम बात करते हैं dipole moment की in NF3 and NH3, even though the difference is due to in the dipole moment in these molecule, you can see 1.48 and 0.2 is due to the fact that dipole moment due to NF bond in NF3 are in opposite direction to the direction of the dipole moment of lone pair of nitrogen, in which they partly cancel out. So when we see the structure now, fluorine, and there are lone pair of electrons here. Okay, for nitrogen with hydrogen, hydrogen, and hydrogen. So what is happening here? Yeah, what is happening here? There are lone pair present here. Okay, so यहाँ पे जो हमारे dipole moment की दिशा है, the direction is like this way, and with it is combining with the direction of lone pair. That's why its dipole moment is more. On the other hand, here what is happening? The dipole moment direction is reverse of the lone pair of electron, and that's why it cancel out some dipole moment, okay, with the lone pair of electron, and that's why it is having the less amount of dipole moment, right? There is a cancelling of dipole moment here. So the dipole moment of NH bond in NH3 all are in the same direction, as I have shown, all are in same direction. That's why dipole moment of lone pair of nitrogen atom which adds up, and it is shown like this way. ठीक है, तो आप देख सकते हो यहाँ पे क्या हो रहा है, यहाँ पे कैंसलिंग हो रहा है, ठीक है, और यहाँ पे कैंसलिंग नहीं हो रहा है. दैट्स व्हाई इट इज हैविंग मोर. सो हमारा जो ऑप्शन सी है वो करेक्ट आंसर. Yeah, next, which one of the following order is not in accordance with the property stated against it? तो यहाँ पे हम लोगों को फिर से उस प्रकार का ही प्रॉब्लम है कि प्रॉपर्टी दी हुई है और किसके लिए वो ऑर्डर मैच नहीं हो रहा. ओके, ऑर्डर इज नॉट मैचिंग. ओके, फर्स्ट CF2Cl2 Br2I2 bond dissociation energy. Okay, so here you can see the bond dissociation energy for these atoms is 38, 57, 45.5 and 34.6. Okay, so lower value of bond dissociation energy of fluorine is obtained. Okay, so यहाँ पे order actually क्या होने चाहिए? Then C2, Br2 and then I2. Okay, and then I2. So fluorine is having very low bond dissociation energy. Why is it so? Due to its high interelectronic repulsion between non-bonding electrons which are present in 2p orbitals. Okay, and that's why it is having low dissociation energy. On the result of this, FF bond is become weaker. FF bond जो है हमारा वो weak है, इसलिए उसको कम एनर्जी लग रही है रिप्लेस ब्रेक करने के लिए. But as compared to chlorine and bromine atoms, ठीक है, FF bond हमारा weak है. और आई बॉन्ड हमारा क्या है, स्ट्रॉन्ग है, इसलिए उसको ज्यादा बॉन्ड डिसोसिएशन एनर्जी की जरूरत है। ऑक्सीडाइजिंग पावर इस तरह से होती है, एसिडिक प्रॉपर्टी इस तरह से होती है, इलेक्ट्रोनेगेटिविटी भी इस तरह से होती है। दैट्स व्हाई ऑल आर ट्रू, बट फॉल्स कौन सा स्टेटमेंट है, ये स्टेटमेंट है। दैट्स व्हाई दैट वाज आस्क्ड, सो दैट इज अवर आंसर। ओके एवरीवन, या नेक्स्ट प्रॉब्लम, इन विच ऑफ द फॉलोइंग मॉलिक्यूल आर ऑल द बॉन्ड्स आर नॉट इक्वल। हम लोगों को NF3, BF3, LF3, CLF3. So we need to consider here the molecule in which bonds, okay, bond length between NF, BF, ALF and CLF किसमें equal नहीं है. So when you see the structure of CLF3, it is T-shape in nature. It is what? T-shape in nature. So what is that T-shape? So chlorine atom is at the center. Okay, chlorine atom is at the center and fluorine are present like this way. So two are present like this way and two are present like one is present like this way. So here इक्वेटोरियल में एक फ्लोरीन प्रेजेंट है, ठीक है, और हमारे जो एक्शियल में टू, ये एक्शियल वाले है, ठीक है, और ये इक्वेटोरियल वाला है. So the bond length between Cl and fluorine present at the axial position ना, it is what 1.70 angstrom. On the other hand यहाँ पे जो हमारा इक्वेटोरियल पे प्रेजेंट है उसका जो बॉन्ड लेंथ है वो है 1, ठीक है, 3 and 170. So that's why their bond angles are different. Some are present at axial position and one is present at equatorial position, due to which their bond length is different. So इनका जो bond length है सारे bonds जो है वो same नहीं है, ठीक है. Next, which is the correct relationship between pH of isomer solutions of sodium oxide, sodium sulfide and sodium selenate and sodium tellurate. तो यहाँ पे हम लोगों को pH दिया हुआ है solutions का. कौन कौन सी solution है? सोडियम ऑक्साइड, उसके बाद है सोडियम सल्फाइड, उसके बाद में है सोडियम सेलेनाइड और सोडियम टेलराइड, ठीक है. यहाँ पे इसको अगर मैंने pH1 कहा, इसको अगर pH2 कहा, pH3 and pH4, right? So you can see the basic character go on decreases down the group for these given molecules. Okay, basic character go on decreases means which will be the most basic. बेसिक कैरेक्टर ऊपर से नीचे डिक्रीज हो रहा है, तो पहला जो होगा दैट इज मोस्ट बेसिक. जो ज्यादा मोस्ट बेसिक होगा उसका पीएच क्या होगा? यस, उसका पीएच क्या होगा? ज्यादा होगा. सो दैट्स व्हाई ऑप्शन ए विल बी करेक्ट. pH1 over pH2 or pH3 over pH4, they will have more pH, right? Yeah. Next problem, right? We know that more basic compound, more is the pH, since pH is directly proportional to basic character, and that's why this will be the answer. Very good. Next, which of the following oxide is expected to exhibit paramagnetic behavior? So here we need to consider the paramagnetic behavior of the oxides. Okay, see the structure of CO2 and SO2. Okay, यहाँ पे CO2 मैंने लिखा हुआ है, यहाँ पे मैंने दिया हुआ है SiO2. Here you can see here is SO2 and here it is what? CO2. Right? So in these four molecules, we need to see which is paramagnetic in nature. So here in CO2, it is a diamagnetic. SiO2 is also diamagnetic. SO2 is diamagnetic, but paramagnetic is what? Cl2 molecule. So that's why here our answer will be what? Option D, which is having paramagnetic in nature. Okay? क्यों paramagnetic है? क्योंकि यहाँ पे जो हमारी molecule है वहाँ पे magnet form होगा यहाँ पे, ठीक है? That's why यहाँ पे जो मैग्नेटिक मोमेंट्स वो कैंसिल आउट हो रही है, लेकिन यहाँ पे वो कैंसिल आउट नहीं हो रही है. स्टेट इज पैरामैग्नेटिक इन नेचर. एनी डाउट्स रिगार्डिंग दिस? Let's move on to the next one. Which of the following would have permanent dipole moment? So among these molecules you can see the structures. Okay, यहाँ पे SiO4 में हमारा सिमेट्रिकल स्ट्रक्चर होने के कारण उसका डायपोल मोमेंट क्या है? 0. नेक्स्ट मॉलिक्यूल इट इज नॉट सिमेट्रिकल, दैट्स व्हाई इट्स डायपोल मोमेंट इज नॉट 0. यहाँ here also 0, here also 0. So option B, SF4 is having dipole moment. Next, among potassium, calcium, iron, zinc, the element which form more than one binary compound with chlorine is. So here binary compound is one made up of two different elements, right? So binary compound means हमारा molecule है जिसमें क्या है? 2 atoms present है, that is binary. So this can be one of each element such as CuCl2 or FeO. These can also be several of each elements like Fe2O3 and SNBr. So metals which can have variable oxidation number can form more than one type of binary compound, like fluorine, you know, like iron, sorry, not fluorine, Fe, Iron can form different oxidation state from +2 to +3 and said it forms a different kind of binary compounds. So binary compound मतलब क्या, एक एटम और दूसरा एटम अलग एटम, तो इसलिए हमारा आंसर क्या है, आयन है. Among all these metals, iron is the showing most variable oxidation state. That's why it is the answer. Which of the following statement is true? So here we need to find out the true statement. Silicon exhibit 4 oxidation number in its compound. Bond energy of fluorine is less than the Cl2. Manganese 3 oxidation state is more stable than the manganese 2. And elements of 15 group shows only +3 and +5 oxidation state. So here the answer is what? Fluorine is more reactive than chlorine. So the bond dissociation energy of chlorine is greater than the fluorine. हम लोगों ने अभी देखा, ठीक है, कि फ्लोरीन का बॉन्ड जो है वो वीक है, ठीक है. सो वीक है एज कंपेयर टू Cl2. दैट्स व्हाई उसकी जो बॉन्ड एनर्जी होगी वो कम होगी, एंड दैट स्टेटमेंट इज ट्रू. दिस इज ट्रू स्टेटमेंट. ओके, सिलिकॉन का जो है वो ऑक्सीडेशन नंबर 6 होता है, 4 नहीं होता. दैट्स व्हाई दिस इज फॉल्स स्टेटमेंट. नेक्स्ट, मैंगनीज थर्ड ऑक्सीडेशन स्टेट इज मोर स्टेबल. दैट इज नॉट ट्रू. मैंगनीज की जो 2 स्टेटमेंट होती है, सेकंड स्टेटमेंट दैट इज stable than the third statement. That's why this is again false statement. Next, 15 group elements जो है उनकी ऑक्सीडेशन स्टेट जो है वो +3 और +5 नहीं होती है, ठीक है. नेक्स्ट, which of the following order is wrong? Acidic, first ionization potential, basic and ionic radius. So here wrong कौन सा है? Second. Lithium, helium, boron, carbon, these elements to the same period, right? They are present in the same period. But generally the value of first ionization potential increases in moving from left to right. Okay, so in period, what is happening here? The first ionization potential should go on increases, but here due to the small nuclear charge, okay, what is happening? Since the nuclear charge of these elements, okay, nuclear charge of these elements, what is happening to the nuclear charge? It goes on increases in the same direction. Nuclear charge भी increase हो रहा है, ठीक है, न्यूक्लियर चार्ज भी इंक्रीज हो रहा है जैसे जैसे हम लोग लेफ्ट टू राइट आ रहे हैं, ठीक है. बट द आयनाइजेशन पोटेंशियल ऑफ बोरॉन is what? 2s2p1 is lower than that of beryllium because it is having 2s2. Since in case of boron 2p1 electron have to be removed to get b plus, okay, बोरॉन से 2p2p1 से हो गए वो b, देखो बोरॉन से b प्लस हो रहा है, यहाँ पे क्या था 2s2 2p1 था, यहाँ पे क्या फॉर्म हुआ 2s2, ठीक है. सो व्हाइल इन केस ऑफ बेरिलियम, फॉर बेरिलियम व्हाट इज हैपनिंग? बेरिलियम का 2s2 है, इसका इलेक्ट्रॉन रिमूव करने के लिए मुझे उसको कन्वर्ट करना है बी प्लस में, ओके, उसको मुझे कन्वर्ट करना है बी प्लस में. सो दिस कन्वर्जन इज व्हाट? मोर इजीली बिकॉज s इलेक्ट्रॉन वी हैव टू रिमूव, ओके, वी हैव टू रिमूव s इलेक्ट्रॉन. दैट्स व्हाई द ऑर्डर विल बी डिफरेंट. दैट्स व्हाई द आयनाइजेशन पोटेंशियल की जो ऑर्डर होगी ना हमारे यहाँ पे वो डिफरेंट होगी. वो कैसे होगी? इस तरह से होगी, ठीक है. बेरिलियम और बोरॉन में जो डिफरेंस था ना उसकी वजह से हमारी ऑर्डर डिफरेंट होगी. हम लोगों को ऑप्शन में दिया हुआ था इट विल बी सेम एज वी मूव फ्रॉम लेफ्ट टू राइट ना, द आयनाइजेशन पोटेंशियल फॉर फर्स्ट एलिमेंट्स विल बी गो ऑन इंक्रीजेस, बट बोरॉन एंड बेरिलियम इट इज डिफरेंट, ठीक है. बेरिलियम की ज्यादा होगी, बाद में बोरॉन की, राइट, क्योंकि यहाँ पे s इलेक्ट्रॉन हम लोगों को निकालना है, इसलिए ये इजी होगा एज कंपेयर टू रिमूविंग द p इलेक्ट्रॉन, राइट. नेक्स्ट प्रॉब्लम, करेक्ट ऑर्डर ऑफ फर्स्ट आयनाइजेशन पोटेंशियल अमंग फॉलोइंग कंपाउंड्स इज, यस, यहाँ पे फिर से बोरॉन का सबसे कम, ठीक है, देन बेरिलियम, देन कार्बन, देन ऑक्सीजन, नाइट्रोजन, बोरॉन से बेरिलियम की ज्यादा है इसलिए मैंने वो अंदर डाला है, ठीक है. या नेक्स्ट, विच कंपाउंड हैज प्लेनर स्ट्रक्चर? सो सी द स्ट्रक्चर्स ऑफ ऑल द कंपाउंड्स. CF4 उसमें क्या है, उसका स्ट्रक्चर कैसा होता है? उसकी हाइब्रिडाइजेशन sp3d2 होती है. दैट्स व्हाई इट कंटेन्स 2 lone pair of orbitals and 4 bond pairs in it, and that's why it shows the square planar structure, okay, and our option A is the correct answer here. Next, which of the following oxide is most acidic? So you know what happens to the acidic character as we move down the group? What happens? Basic character go on, yes, basic character go on. See here, among nitrogen, phosphorus, arsenic and antimony, former has the highest electronegativity, so its oxide will be most acidic. So nitrogen जो है वो ज्यादा इलेक्ट्रोनेगेटिव होने के कारण the electronegativity for nitrogen is very high, and that's why as the electronegativity value of element increases, the acidic character of acid also increases, so N2O5 will be most acidic. So as we move down, what happens? Basic character increases for the oxide, and the first one will be acidic in nature. Right? Next, which of the following phosphorus is most reactive? Scarlet phosphorus, white phosphorus, red phosphorus, or violet phosphorus? So among the phosphorus, white phosphorus has a low ignition temperature, so it is most reactive among all the allotropes of phosphorus. तो इसके वजह से वो क्या है, ज्यादा reactive है white phosphorus. ठीक है? Which of the following is used in the preparation of chlorine? So यहाँ पे we need to consider which reaction is used for preparation of chlorine. Both MnO2, KMnO4, only KMnO4, only MnO2, either MnO2 or KMnO4. So see here reaction, you can see MnO2, ठीक है, MnO2 और KMnO4, वो दोनों की reaction मैंने की है, और यहाँ पे you can see that both are giving me chlorine. Both are giving me chlorine. So option A, when MnO2 and KMnO4 are both used in the preparation of chlorine. Next, last questions. Repeated use of which one of the following fertilizers would increase the acidity of the soil? Ammonium sulfate, superphosphate of lime, next urea and potassium nitrate. So here the use of ammonium sulfate, which is a salt of strong acid and weak base, which is a strong acid, sulfuric acid, and which is a weak base, NH4OH, ammonium hydroxide. So therefore, repeated use of this ammonium sulfate fertilizer would increase the concentration of acid, while ammonia from NH4OH is used up by the solvent, and hence the acidity of soil is going to increase. क्योंकि NH4OH का conversion अमोनिया में होगा, और वो अमोनिया हमारे प्लांट्स जो है वो एब्जॉर्ब कर लेंगे, लेकिन एसिड जो है वो वैसे के वैसे रहेगा सॉइल में, and that's why that is going to increase the acidity of soil. So ammonium sulfate is the answer here. Next, which of the following has the highest dipole moment? So tell me which will have the highest dipole moment. Yes. So as we know, NH3 का ज्यादा है, अभी हम लोगों ने देखा NF3 से भी ज्यादा है. So NH3 will have the greater electronegativity. Since nitrogen is having the greater electronegativity, that's why it will have the highest dipole moment among all the four options present here. Okay. Any doubts regarding this? Yes, thank you so much for joining in this session. If you have any doubts regarding this, group 15, 16, 17, 18, you can talk to me. You can ask any questions. Yeah. Okay, thank you so much for joining in. Let's meet tomorrow.